Hello, thanks for clicking. Welcome to another Nargilus 2 production. Today we're going to be learning about functions and Taylor series. Okay, we're going to dive a little bit deeper into what we did in the last video, which is take functions and use their Taylor series to write the function as a series. Okay, all right, so let's get started. We're going to use some of the series that we already have learned. So we're going to start with f of x equals sine of x cubed. Well, we already have a series for sine of x, right? So let's write down our series for sine of x. Sine of x, we know to be x minus x cubed over 3 factorial. And again, you should know these off the top of your head. Plus x to the fifth over 5 factorial minus, I'll just write a couple terms there, plus, and then we have negative 1 to the n, x to the 2n plus 1 over 2n plus 1 factorial. Okay, that would be my general term. Now, I want the series for f of x equals sine of x cubed, not the series for sine of x. Well, what's happened between sine of x and sine of x cubed? Well, x has been replaced by x cubed. So to write the series for f, that's exactly what I'm going to do. I'm going to replace x with x cubed. Every time you see an x, you're going to put an x cubed in its place. That's all you have to do. All right, we're going to have to clean it up a little bit, but it's not too bad. All right, so we replace x with x cubed, and then we'll have x cubed minus x to the ninth over 3 factorial plus x to the 15 over 5 factorial minus plus negative 1 to the n. That's just going to be x to the 6n plus 3 over 2n plus 1 factorial. So the sum, the series, the general term, is negative 1 to the n, x to the 6n plus 3 over 2n plus 1 factorial. And that's the right answer. Okay? This is the series, or the Taylor series, for f of x. All right? That's what we're doing. Again, it's a continuation of the last video. The function and the series are interchangeable. So instead of doing something with the function itself, sine x cubed, you can do it with the series and the series terms, and you'll get the same result, but you'll get the result as a series. Okay, let's write the first 4 terms in the general term for the Maclaurin series for cosine. All right, so let's start with that. Cosine x, let's see. So cosine x is 1 minus x squared over 2 factorial plus x to the fourth over 4 factorial minus x to the sixth over 6 factorial. And then the general term is negative 1 to the n, x to the 2n over 2n factorial, right? It's the derivative of the series we just had up for sine x. Okay? All right. And again, all these terms I could get by deriving the sine x terms if I wanted to. Okay, now, what are the first 4 terms in the general term for the function x cosine 2x? All right, so what's the difference between cosine x and x cosine 2x? So let's do this. I replaced x with 2x, and then there's an x that's being multiplied by that. So I'm going to do this in 2 steps. I'm going to start with cosine 2x. So to write the series for cosine 2x, I'm going to have to substitute in for x, 2x. For every x, I'm putting in a 2x. Okay, so let's do that first. We'll do it for the general term as well. 2x to the 2n over 2n factorial. Okay, we did that. Let's see. We can clean this up a little bit if we want. Is it worth it? Yeah, I guess we're going to have to. So cosine 2x is going to be 1 minus 4x squared over 2 factorial. All right, I'm not going to simplify the 4 and the 2 squared, or 2 factorial. I'm going to leave it there. 2 to the fourth is 16, x to the fourth over 4 factorial. And then we're going to have, oops, this is a minus here. So we're going to have minus then 2 to the 6th is 64, x to the 6th over 6 factorial, plus, that's going to be negative 1 to the n, 2 to the 2n times x to the 2n over 2n factorial. All right, so that takes care of that. Now, I want the function x cosine 2x. So I'm going to have to take all of these terms and multiply them by x. So each one of these terms in cosine 2x are going to get multiplied by x. So let's see. 1 times x is x, minus 4x cubed over 2 factorial, plus 16x to the 5th over 4 factorial, minus 64x to the 7th over 6 factorial, plus negative 1 to the n. 2 to the 2n is not affected by x. X times x to the 2n is x to the 2n plus 1. There's one extra 1 over 2n factorial. And there's my function, or my general term, for x cosine 2x, for f of x. All right, and the first 4 terms as well. Okay? All right, so hopefully we get the hang of this, see what's happening. All right, finally, let's write the first 4 terms in the general term for the Taylor series. G of x equals e to the negative x squared. All right, so again, e to the x. E to the x is 1 plus x squared over 2 factorial plus x cubed over 3 factorial. Again, you got to know these off the top of your head. The general term is x to the n over n factorial. So e to the negative x squared, I've replaced x with negative x squared. So let's do that. It's going to be 1 plus, we'll write it like this first, negative x squared plus, negative x squared, sorry. Just negative x squared. And then we have negative x squared over 2 factorial, negative x squared cubed over 3 factorial, and then my general term, we'll put it down here, is negative x squared to the n over n factorial. So if we clean this up a little bit, e to the negative x squared is 1 minus x squared, let's see, plus x to the 4th over 2 factorial, minus x to the 6th over 3 factorial, plus, if I take this negative out, raise it to the n power, it gives me negative 1 to the n, x to the 2n over n factorial. All right, now, what do I want to do with this? Well, now I want to find the limit here in part B as x goes to 0 of 1 minus x squared minus g of x over x to the 4th. Whoa. So this is g of x, right? So I am going to replace g of x with the terms in this series. I'm allowed to do that. Leave the 1 minus x squared there, minus all these terms. So 1 minus x squared plus x to the 4th over 2 factorial, minus x to the 6th over 3 factorial, plus, then there's a general term, negative 1 to the n, x to the 2n over n factorial, all over x to the 4th. All right, now I'm going to clean this up. If I distribute the negative to all of these, well, the 1 minus 1, they drop out. Negative x squared minus that drops out. And I'm left with the limit as x approaches 0 of negative x to the 4th over 2 factorial minus plus x to the 6th over 3 factorial, negative 1 to the n, x to the 2n over n factorial, all over x to the 4th. Now, I want to find the limit as x goes to 0. If I substitute 0 in, you can see you get 0 over 0. That's indeterminate. You can use L'Hopital's rule to do this. Or what you could see, if you see it, you can factor out x to the 4th in the numerator and knock out the x to the 4th in the denominator, which is what I'm going to do. So I'm going to factor out x to the 4th up on the top. It gives me negative 1/2 plus, I took 4 powers of x out of there. It leaves me with 2 of them. And then I'm going to take 4 powers of x out of here. So that's 2n minus 4 over n factorial, all over x to the fourth. The x to the fourths cancel. Now, as x goes to 0, anything that has an x will literally become a 0. So that's a 0. The general term's also 0. And all the other terms in between here are going to be zeros because they all have x's in it. So the only thing left is negative 1/2. And that's the answer. So again, the idea here is as follows. You need to understand that this series representation for e to the x can be used in place of e to the x, or it can be used to create a new series involving some variation of e to the x or some other function that's similar to it. And then you can use this series in any way that you want as if it's called this function, because this function and this series terms are the same thing. They represent the same thing. Okay? And that's it. As always, thanks for clicking.